All right, well, hey, this is Baking A to Z, and thanks, Mark, for our introduction. We'd like to get into some terms and definitions that will just kind of help keep us on course as we talk about the things related to baking profiling. And even profiling is the first word we want to get a good definition of, because a lot of people use the word profile or profiling for different meanings, which will become clear in a second. But basically, profile is a graphical plot of temperature versus temperature or humidity in the baking process, or temperature or humidity, obviously on the y-axis, or versus time, is measured in one or more points of interest. So as a result, time, off to the right, and temperature together make up what we call a profile. Basically, again, a graphical plot of the temperature or humidity versus time. A lot of people confuse the word profile with the settings for their oven, which we use the term set points. In some cases, we'll use the word recipe. In baking, we try to avoid the word recipe because usually recipe refers to the ingredients that are being baked as opposed to settings in the oven. So set points are quite often, most often, the word used to describe the oven settings required to produce a profile. And they may include temperatures, of course, temperatures of various zones, and they often include the time it takes to bake, which ultimately adjusts the conveyor speed. The final term is actuals. Actuals are the current value, and when I say current, they're always moving. They're never exactly the same all the time. Set points may, for example, in this oven here, the set point may be 450 degrees, but the actual value in that zone, and again that's average, at the point of measure may be 440. So the current value or current oven conditions as compared to the set points is always interesting to note, because again, what you set it for and what it actually is running at are quite often two different things. And it's always good to know when you go to do a profile to produce this graphical plot, it's always good to know what the actual oven conditions are in addition to the set points during that profile time. It can help you judge what a better set point might be should you need to change the oven, knowing that the actual tends to be a little different. Usually it's less, but it can sometimes be more. Some additional terms are things that we pull from the profile once it's been taken. It includes the start, or start temperature. It is basically the internal dough temperature as it enters the oven, or as it exits the proofer in most cases. This is an important measure to make. You don't want to be too warm or too cold as you come out of the proofer. End temperature. This is the internal temperature of the dough as it exits the oven. And then finally, the bake time, the total time, believe it or not, between the start temp and the end temp. That is the ultimate bake time. We realize that bread especially continues to bake long after it exits the oven. However, we define the total bake time as that between the start and end temperature measurement points. That is just the best way to draw the line where you call the end of the bake, even though the bread is still baking, even as it's headed down the conveyor belt to the slicer. There's still a certain amount of heat in the bread, and it is still having its impact. There are certain requirements from the baking process. Yeast kill, and it is usually measured as a percent of the total bake time. It is the percent of the total bake time required for the internal dough temperature to reach the yeast kill temperature. Usually appears somewhere about halfway between the start and the end temperature, and we'll discuss the temperature values in a minute. So if the total bake time is 20 minutes, 60% of that 20 minutes would be the 18 minutes it took to get that, sorry, not 18, 6 times 2, 12 minutes it took to get to the yeast kill temperature, or 60% of the total time. There is the arrival time, arrival temperature, which is also a percentage of the total bake time. And that is defined as the time it takes to reach, again, a particular temperature. In most cases, that temperature is around 200 degrees. And the targets we're shooting for, we'll discuss here in just a few minutes. The baking process has a very simple task. As time and temperature happens, here's your plot. You're trying to take the bread from this, or I should say the dough, over time, finally to this. And its main purpose is to generate good color, a desirable taste. We're trying to prevent mold or mold prevention, increase stackability, not so soft that the stuff goes flat as you stack it, and then finally the longest possible shelf life. That's what baking does to the dough. Simple as that. And the oven settings required to produce the perfect profile is what your goal is. And we're going to talk a little bit how we do that. Most bread baking requirements demand the following: yeast kill at around 140 Fahrenheit, gelatinization around 170, and arrival at around 200. And we're shooting for roughly yeast kill between 50 to 55% of the bake time, gelatinization between 60 and 65, and finally arrival between 85 to 88 or 90% of the total bake time. These are typical targets that you're shooting for as you bake bread. This runs across most ingredients. There are some ingredients out there, especially the synthesized enzymes and whatnot, that are in common that may vary a little bit from this. Your enzyme manufacturer will be able to tell you what these temperatures should be and the percent of bake time that they recommend as you produce your profile. So what's needed to profile? Actually quite a little bit, and I'm going to mention every little nuance. I may leave out some things, but it's a hurried mess down on the baking floor. As you all know, things are flying around rather quickly. You don't have time to second guess, so we're going to give you a nice list of things that if you have in your back pocket, you'll be ready to go. One thing that you won't lack is something to profile. We deal in a lot of industries where a product to profile is sometimes hard to find, but at 60 to 120 loaves a minute coming out of the end of the oven, product to profile is usually easy to come by. And thankfully, that which you use for profiling ultimately gets used, if not for people, for animals. So there's very little waste involved in the baking process. So that's excellent. We have no problem finding handfuls of ingots, as I call them, ready to profile. You're also going to need thermocouple sensors. And I want to emphasize the word thermocouple. I've heard various distorted pronunciations of that word. I won't say them because I don't want to forever stick them in your minds. But thermocouples are the sensors that are used in most profilers. They're certainly the ones used in our profiler. Thermocouples are two different metal a pair of conductors that are of two different alloys that are designed to produce a changing voltage with changing temperature, and that's ultimately what tells us the temperature inside is the temperature of the end of these tips. We'll get into that in just a moment, a little more. You're going to need a profiler. That's where these sensors plug in. First, we're going to show you our products. That's our M.O.L.E Super M.O.L.E Gold 2 thermal profiler. You're going to need some form of thermal barriers. This is to protect the M.O.L.E through the oven. Sad to say, we've had people put the M.O.L.E in all its glory right through the baking oven without any protection, and no surprise, it comes out as baked as the bread, and of course no good anymore. So thermal protection is required. This is a typical barrier you'll see used for bread baking. You'll need calipers. We'll get into why you need those a little more detail. They don't need to be quite as fancy as this, although these plastic calipers are very inexpensive. It is very helpful, all the little angles and bends these calipers have for using them to set up your thermocouples for proper insertion into the bread, into the dough. A stopwatch, you might think, well, good grief, I'm measuring time and everything else, but this is to help remind you what time it is and when to be at the end of the oven to catch all this stuff out the other end. A very important piece to have with you. Pencil and paper, we'll tell you about that in a minute, but have that handy. You will need it. You will need a computer. Excuse me. You won't have that down on the floor, most likely. Most environments in the baking industry simply don't support having a computer of any form or another handy on the floor, but you will need it. You will need the software. Software usually is designed to go with the product in question, in this case our M.O.L.E map software, along with the Super M.O.L.E Gold. And you will need gloves. I personally like to bring my own because the ones that they typically provide on the baking floor I'm not used to using. They tend to be open-backed, and it scares me to be picking up hot pans. Some of these guys will pick up the pan with their hands. I don't know how they do it, but I recommend you have some kind of gloves. Keep yourself from getting hurt. And then a cooling fan. This is to cool all this business off before you use it again. That can take many forms, as you well know. If you put enough time between profiles, cooling fan is not necessary, but you can be profiling again in 20 minutes if you have a way of cooling the barrier in the M.O.L.E back to room temperature as quickly as possible. Fans work really good for that. So these are the things you're going to need to do a good job of profiling. You're going to need to set up the M.O.L.E. Using our software, the setup procedure looks a little bit like this. We totally recommend that you use a 1-second log interval. A lot of people are inclined to make it 5 or 10 seconds because, after all, not a whole lot changes very quickly in the baking process. But you'll find that 1 second, there's plenty of room for data. There's no reason to be stingy on how often you record. You'll find that the increased log interval, especially with regard to oven temperature, is very helpful to see just exactly the dynamics of what's going on inside the oven, as well as giving you lots of data about what's going on inside each loaf. So 1 second log interval, all channels on. The M.O.L.E that I showed you on the previous slide has 6 channels. Turn them all on. You're going to use every one of them. So you set 1 second, all channels on, and you're ready to go as far as the programming of the profiler. That's all you need to set up in the profiler itself. Thermocouples, as we talked about or mentioned earlier, are a bi-metal 2-conductor temperature sensing device. You might say, well, how can these 2 wires that come out of here connected together measure temperature? And they do so by the fact that they are 2 different alloys of material. And chemically they produce a voltage as the temperature changes. It's important that that thermocouple have the two wires meeting at one point. This is where the temperature is measured at the welded bead at the end. What you don't want is a bead and then an extra twist. Don't have these conductors connecting together at any other point along their entire length. Quite often the insulation, if you're not careful, will get burned or damaged just because of over-bending or too much bending. And if you've got a short along the length of the wire somewhere away from the bead, whether it be right near it or somewhere along its length, you're not going to get good readings. And quite often I get calls, well, how come the temperature didn't go as high, or how come the temperature went too high? It's all because there was an extra connection in the wire. So treat your wires carefully. Make sure the TCs are good. Make sure each TC wire is separate before you begin to use it. It's amazing how easily they tangle, but they are Teflon. They separate quite nicely and quite easily. The insulation, that is Teflon. So get them separated, because you're going to need to get them apart from each other in order to get them into the bread. And you got to work fairly quickly. So before you grab the pan off the line to start instrumenting it, have your TCs ready to go. Identify TC number 1. You want to use TC number 1 for the ambient temperature, and we'll show you how to set that up in just a moment. Set your caliper for about half the projected bake height for spring. If you expect your loaf to be 4.5 inches high when you're done, set your caliper for 2¼ inches. And then we're going to bend each of the channels 2 through 6, that's 5 thermocouples of course, at that 1/4 inch. That bend is your guide to how deep into the loaf you're going to insert it. It's important that each thermocouple go the same distance into the loaf. As those pictures of the bread being baked showed, you want to make sure you're sensing the center of the loaf where the dough takes the longest to finally turn into good-looking bread. And that's why the center, or half the distance of the overall height of the loaf, is the important measurement to make there. So you want to make sure each thermocouple is inserted in the same amount. So put your bend right here. That is where you're going to stop the insertion. Pan prep, and this is the part where you want to get good at it. This is the part where you need to be quick and efficient. You might want to practice it more than once, but you will get very good at it. This is, of course, where you can also get hurt, so use extreme caution. Grab a pan off the line. Most baking processes have 5, some may have 4, some may have 6. Take the pan nearest the center, take that raised dough out, split it about in half, stretch it out, put half of it in the bottom. The reason why we do that is it's just extra protection for the barrier. Today's barriers, some of the new ones we have out, don't demand that anymore, but the older barriers that are still out there, it's certainly helpful to put a little dough on the bottom and the top of it just to help keep it cool. It's cheap insurance. You're going to throw that wad of dough away anyway. You might as well use it to help protect your mold from getting too hot. So place the barrier down onto the dough with the lid open as you show here. Here's your ambient sensor, number 1. Typically there's these links between pans. Just wrap that carefully around that first link and have it sticking up. It can be anywhere from 1 inch to 2 inches above the height of the dough. It's not super critical. It's going to tell you what's going on in the oven at or near the temperature of the loaf. You may choose to use the second channel for ambient. That's okay as well. In this case, the blue is the second channel. For the most part, 1 channel in the air is sufficient. Save your other 5 channels for looking as many places on the loaf as you possibly can, or loaves. You want to start the profiler at this time and go ahead and close it up. As you lay out the rest of the thermocouples, avoid tight twists and kinks. That's what's going to damage those thermocouples sooner than later, so don't pull them up super tight, especially where they are being bent. Nice, gentle twist is all you really need to hold those in place. More pan prep. The trick is to insert the TCs along the center of the bread. You can put 2 per loaf, or you can take one of them and put it in each loaf at the center, depending on how many are in your pan. You want to insert it to that bend point we pre-bent the thermocouples at, in this case at 2 1/4 inches, and then pinch the dough at the insertion point. That's to prevent 2 things. It helps keep the thermocouple from pulling out, and it also keeps gases from exiting the hole you just made in there, which can have an effect on temperature as well as the overall bake time in that spot. Again, 2 in each dough piece is good. If you have more dough pieces in the pan, you can spread them out 1. But 2 in each dough piece gives you a better chance of knowing the total bake time in that loaf, because the one that takes the longest is really the total bake time. Use the dough to secure the wire in other places. Just pinch the dough along here. That helps. This is not an insertion. Again, the insertion point happened over here. This is just to help hold the thermocouples in place. That way, as this thing jostles around the conveyor, you don't have the risk of these thermocouples being pulled out. And this whole process is going to take you about 1 to 2 minutes. Put the remaining dough half on top of the barrier. As you notice, this barrier sets just a little bit crooked in this particular pan. Some pans are extra wide, some are extra long, some it drops right in, some it has to sit a little bit funny. That's quite all right. Drop that dough piece on there. That's the final security for your thermocouples. Make sure any excess wire are tucked down in here and held down by the dough. So the last thing you need is one of these thermocouples getting hooked up on some of the mechanism of the process. Loading the pan on. By all means, do not attempt to load this pan at the loader. In fact, most ovens have light curtains that aren't going to let you even get anywhere near it. Do not attempt to load it there. Do it at the grouper. Find the middle of the group as you can. But before you even get going, make sure that the operator is aware that you're going to be doing this. And if you are the oven operator, bless you, because most oven operators don't profile. They usually save that for someone else to do. However, oven operators can do this, but if you're coming down onto a line, make sure you've connected with the operator first, and always ask for assistance. Don't do this alone. Have at least 2 people involved in this process to help you out. You're going to want to set your stopwatch to the bake time, preset it. Know exactly how long the bake time is, and remember that ovens don't exactly always do what they say they're going to do. So remember to be back early. Again, place that pan on the grouping conveyor, about in the middle, if at all possible. If you've got 14 pans going on in each group, take out the 7th, move it to the back, and put your profiling pan right in the middle of that. You'll notice to double check the clearance, and that's not just through the oven. The grouping conveyor has all kinds of clearance issues, including water nozzles and all kinds of butter applying things that might be spraying across the top of each of these loaves. So make sure you've got clearance through that. In this case, you can see our pan here. I'm sorry, the barrier with inside this particular pan. And this was in the middle of a group of 13. Make sure you got plenty of room through that oven. That's a visual check before you finally let this thing go. Start your stopwatch as the loader pushes the pan. That's the beginning of the bake. while you're waiting. You got 20 minutes to kill, thereabouts, maybe 26 minutes in some cases. If you're doing cakes, maybe up to 30 minutes, maybe a little bit more. Don't leave the area. It's tempting, but there's a few things you can do while you're waiting. I know some guys go out and smoke, and I don't know what all. It's not the best time to go to the bathroom because a lot of things can happen, and you should be there available and ready to deal with it should it happen. So don't leave the area. Go down to the oven's display and record the settings. The oven set points. Each zone has a set point, as we talked about. Record that. Record the oven actuals. Most oven displays will show you what the actual temperature is in each zone. So get that written down, and that's what that paper and pencil are for. Note, of course, the bake time. Take note of any issues that happen in the oven while your profiler is in the oven going through. Any stops, any stoppages, especially, and not just some failure of some kind or some alarm, although those are worth noting. However, you may have product stop. You may have a big gap in the oven. Right after you put your pan on, all of a sudden the line is stopped and you're not feeding any more loaves, any more dough into the end. You may be putting it in near the beginning and the majority of the oven is empty. That's worth noting because the profiling of the last loaf through an oven is way different than the profiling of the first loaf through an oven. So it's worth noting. It's best to profile a fully loaded oven. That's going to be the best overall information you can possibly get. I realize that in like all cases you can't do that. But note the conditions of the oven, especially if there's any large gaps in product. Keep an eye on that stopwatch. Time goes by quickly. Be present at the oven early, oven exit early. It could be anywhere from right around the corner to 200 feet down the factory floor through a labyrinth of conveyor belts. Be there early. Stop timing when the unloader delivers the pan. That is your bake time. In spite of what the oven's screen may be saying is the bake time, the real bake time is when the loader finally delivers that pan to you. And that's worth noting. It may be that the conveyor's speed is not correct because of calibration issues. You want to get a good read on how long that bake time is compared to what it was set for. It's possible the oven needs calibration or adjustment. After the bake, set the pan aside. This is one of the most difficult things. Of all the things on a baking floor, quite often there's no place to put anything down. I think bakeries like it that way because that way junk doesn't accumulate. But I've seen everything from the wastebasket where you're going to throw these loaves away to putting it down on the floor because there just isn't a flat surface to put anything. But get it set aside, get it away from the conveyor, out of the way of all those moving pans. And please remember, it's hot. Get the barrier box open as soon as you can. You're not in a huge rush, but you want to get this profiler out away from all the hot stuff is reasonable. Gently take TCs out of each loaf. Don't just grab and run unless you like purchasing new thermocouples, which we don't mind, but they can be damaged. They're probably fairly warm, and that's when they're most vulnerable. So gently remove those TCs. As you can tell, this whole thing's kind of moving because the picture is slightly fuzzy. Once you get the box open, stop the logger. You don't have to stop it immediately, but it's just as well you get it stopped sooner than later. That saves a lot of extra data being gathered at the end of the profile, which you end up having to crop off using the software anyway. Take everything with you, including that pan. Make sure it gets back to the cleaning line or wherever the empty pans end up in your process. If it's your special pan made up for profiling, which a lot of bakers do, they'll make one up specifically for profiling where this center pan will be sized appropriately for their thermal profiler and whatnot. Take it with you. Don't leave anything laying around. And get to your PC where you can download the profiler. Just a minute while we check some logistics. Okay, yeah, make sure you take everything with you. It's so common to leave things laying around, and your oven operators and other people on the floor won't like you very well if you leave stuff laying around. Okay, with the M.O.L.E connected to the PC, the software will give you the opportunity to download it, and you're going to get a profile that looks much like this. The software we generate will automatically, the software we provide will automatically give you these times. There will also be a gelatinous temperature. We didn't talk too much about that, but it'll also be available there. The critical ones that most people pay the most attention to are these 4 values. Make sure your start temperature is what is preferred. Most people don't like it much over 100 degrees Fahrenheit. I've seen some on hot days in Texas be at 106, and that's just too hot. They have to take measures to get the temperature down before it enters the oven. So somewhere near 100 degrees is what most people are shooting for. Yeast kill, in this case at 140. Your desired was 50 to 55. In this case it was 60, a little bit longer than expected. Arrival at 200 degrees happens usually between 85 and 88%. In our case, it happened at 79, so a little bit early. What that typically means is because this is late, we were not heating enough in the beginning and pushing the heat in way too much near the end. So set point adjustments may be made. Most people start their ovens out at almost all the same temperature in each zone, and that's a great place to start. Try to avoid the first zone high, second zone low, second zone, third zone high, fourth zone low. Any kind of stair step, sorry, not stair step, but up and down in zone to zone is usually an indication that you can probably turn them all down instead of having them up and down, up and down, up and down. Most people will end up, again, start out with them all the same temperature. They'll find that they need to either increase the first couple zones perhaps, maybe decrease the last couple zones. And that's about all the adjustments that are going to be necessary in your oven to get these type of percents of bake time to achieve these yeast kill and arrival temperatures that are desirable. That is all it takes to profile. The software that you're going to be getting with our M.O.L.E will again provide these values for you. And it used to be you had to get your calculator out to figure out all these percentages. They're now given to you at the instant you download the M.O.L.E. Check your start temperature, yeast kill and arrival temperature, and the percentage of the bake time. Make sure your end temperature is at or around 203 to 207. That's very common end temperatures. And you've got a well-baked loaf of bread. And better yet, you have proof that you've baked it as you had intended to, now that you've actually measured the temperatures through your oven. So we went over our terms and definitions. Went through the requirements for a good baked loaf of bread. Went over the equipment needed to do profiling. We set up the profiler, which is as simple as setting the log time and the channels on. We got our TCs attached. inserted into our loaves, and finally we ran the profile through the oven and ended up with a good profile at the end. We appreciate your attending here. I wanted to mention that some of the illustrations and pictures were used by permission, and they were provided by our friends at M.O.L.E and our friends at Bimble Bakeries USA. We thank them for that content and those images that we were able to use here today. All of them were taken on the real floors and real places, and we appreciate their cooperation in that. If you've got questions, we would love to help answer them. There are more ECDU classes, including our Baking 101, which gets into much more detail about using our math software for the analysis of the profile, and a little more in depth on how that all goes together, and that's coming up in the next few weeks. So take a look at ECDU, look at the training tab to get a look at the classes that are coming up in the future. Appreciate your attendance today, and we hope you have a good rest of the day. Thank you so much.